In today's video is going to be the first video to show you how to control just about anything over the cloud or over the internet, whether it be on 4G, 3G, 2G, whatever it might be. So what are we doing today? I'm going to be showing you how to control the inbuilt LED over the cloud. And let's go to switches, and we're going to be able to turn it on and off. As you can tell, the LED turning on and off. Now, I decided with this because there's no soldering and everything is pretty straightforward, and all you need to do is plug it in and prepare the firmware, and this gives you a better understanding of how everything is going to work. Now, if you take a closer look here, no Wi-Fi, no Bluetooth. I'm connected on 4G. This is connected on my studio's router, and I could just constantly spam the on and off button right there, and it'll be perfect every single time. This is the latency, and obviously we could still optimize for more latency, but it doesn't really matter because it's a switch, and we'll be able to do more things later on, live sensor data, RC controls. But I wanted to start out with the basics here. Now, something very important to keep into consideration here before we start, if you do refresh this, it'll no longer connect, and the reason for that is because it's a bug and I just found out. Another thing, if it's been open for too long in the background, it'll automatically disconnect you. So you're going to want to open switches again, go to a different page and come back to switches, and that'll allow the phone to connect back to the server here. So what's really going on here is you are actually just sending a 1 and a 0, and it's deciding what to do with that 1 and 0. And later on, obviously, I'll be showing you how to do the RC control. But right now, it's just the basics, just to get your mind around how everything is functioning. And again, before we begin, make sure you check out the flashing MicroPython tutorial, or none of this will actually work. So I'll have the playlist down below, because that video is the foundation of everything else that we're going to be doing with these projects. So I don't have to keep showing that part. And with that being said, a word from our sponsor, and let's get started. The sponsor of today's video is PCBWay. If you have any projects that you want to get done and or assembled, then PCBWay is going to be a great choice. I've been using them for the past couple years, and by far one of the best services I've used, whether you're a hobbyist and or professional alike. So definitely check the links down below. Alright guys, so now we're going to go ahead and get everything ready and showing you how everything works. So the first thing you need to do is obviously create an account on IoT Push, which is the system I've designed, and also you'll need the application. It's both available on iOS and Android. Now, before you actually create your account, you need to take something into consideration. If you're going to log in through the Apple login or Google login on your phone, then you should do the same thing from the web panel, so you have everything connected correctly. So keep that in mind. If you decide to create just a normal account, then make sure you log in the same method on your phone. Very important you know that right now. So I'm going to be using the Google login method, and yeah, once you log in, then you're greeted with this page right here. Now, the first thing we want to do is we want to go to manage sensors. That's very important we do that. And you need to take into consideration which one you click on, because you won't be able to control if you actually create the wrong sensor. So for our case, we're going to do the switch. We'll cover the live data and control later, but we're going to do a switch. So something very basic that turns on and off. So we're going to go ahead and click switch here. I'm going to delete this right there. And in this area right here is where we enter the sensor's name. And it's very important, even the case sensitivity does matter. And once you create it, it'll be down here. So let me go ahead and create one. So I'm making one called LED. I'm going to click submit. And now I have LED. Now make sure you always copy it from down here, because if it decides to add a special ID for you after that, this is the one you want to grab, not the one you just wrote, whatever it gave you down here. So we called it LED, and in our case it's LED. So we're going to keep this page right here open. Next thing we want to go to is we want to go to token and documentation here. So let's go ahead, token and documentation. And we see this link right here. We're going to go ahead and open it. It's going to take us to the GitHub repository. Now, this is where all the projects will be. And if you ever need any project, this is where I do them before I upload the video. Actually start writing on before I upload the video on these, so you can actually follow along here on this page. So what we're going to do is we're going to take this link, we're going to copy it, and we're going to open VS Code. Now, if you don't have the correct environment set up, please watch my previous video. I'll have the playlist down below. It starts right from the beginning to prepare your environment, so you can always follow along here. So let's go ahead and open Visual Studio Code together. All right, so now we have Visual Studio Code up and running. What we want to do is we want to click Clone Repository here. So we're going to click that, and we're going to paste that link, the GitHub link that we just got, and we're going to click Enter. Now, once you go ahead and click enter, then you're going to have to choose a directory where you want it to save all of those files, because there's going to be quite a lot of files in that repository. And we're going to go ahead and I've already chosen LED tutorial on my D drive. So I'm going to go ahead and select that and just let it clone. So it's cloning that repository, which means it's downloading. And then we're going to go ahead and click open down in the right. Sorry, you can't see it right now. Just noticed that. You'll see open right here. So we're going to go ahead and click open. And that should open up everything. So you're going to have access to everything here. So the first thing we need to do is we need to go into the MicroPython projects, and you need to figure out which one you're using, the ESP8266 or 32. But for the sake of this tutorial, we're going to be using the ESP32. So we're going to click the ESP32 folder, and under it should be the projects, but currently we only have one. And we're going to go ahead and click on the project one here, and we're going to click on main. So that will open up the main file that we need in order to get this up and running. So once you open up main, then you want to open the README right under it, right there. So we're going to open that as well here. And this has some good information, but we're going to want to scroll down to the flashing part because we're going to need a tool which we didn't cover in the setting up process because I kept it for a little bit later. I didn't want to go ahead and spam you with a bunch of information. So once we go into the README, we'll see flashing the files here. So we're going to need this tool right there. And again, if you missed the previous video of how to set everything up here, then definitely go check that one out. So we're going to click on this down here where it has the X, and it should open this up, and we're going to click terminal right there. So the first thing we're going to do is we're going to go ahead and grab this command right here, pip install. We're going to install, this is the tool from Adafruit, and it'll allow us to send the data or send the files to the ESP32. So we're going to go ahead and click send. All right. And obviously make sure your microcontroller is flashed with MicroPython. Just give this some time. It should install. So the next thing we need to do is we actually need to go into the correct directory, or none of these commands are going to work that I'm about to show you. So the way we do this is we're going to go CD, and then we're going to type micro, and I'm going to press tab, and it's going to finish it to MicroPython projects. Then I'm going to choose my ESP32. So I'm going to go CD ESP32, press tab. It should continue it like that. And now we're in here. I'm just going to clear this so it could be in the middle of the screen. So now we're in the ESP32 directory. Now, just to double check if we're in the correct directory, we could write dir, and we can see what's inside. So we can still see that we're still not inside the project folder of project one. So we're going to go ahead and type cd p, and then we could press tab, and that should complete it right there for us. And now we're inside. So there we go. Let me go ahead and bring this up a little bit more here for you guys. Okay. So now we're going to go ahead and press dir. You could do ls if you have PowerShell, but I just remembered some people are just still on command prompt. So you could do dir. And now we can see, this is what you have to see. WebSockets and main.py. That's very important. You see those. Okay. So now we're in the correct directory here. Now WebSockets is a folder with the correct libraries in order to connect to the server, which I've gotten from obviously the internet, and I've also modified in order to work with the server's connection. So you really don't have to look at that. All we really have to pay attention to is the main.py. So the first thing, let's go ahead and upload these files in order for the ESP32 to be able to connect to the server and your account, and for you to be able to control it. So the first thing we need to do once we're in the correct directory is we need to figure out what COM port, and obviously your ESP32 should be connected. What COM port is the ESP32 running on? We can do that by typing the Windows key and just writing device manager, and we can click enter. And we can scroll down to COM ports. You can see ports, COM3. This should be available. If it's not, then look up some tutorials on how to download the driver. So as you can tell, we are on COM3. So make sure you take note of that, because everything else will rely on COM3. So here I already have mine set to COM3. If yours is COM8, you want to change the 3 to an 8 here, and on the rest of these commands here. So mine's a COM3. So what I want to do is I want to grab this one. Now if .exe doesn't work, then you do .py. So let's go ahead and copy that. And what this is going to do is it's going to use COM port 3, and it's going to make a directory on the ESP32 called WebSockets. And every letter counts here, so you don't want to screw something up. So I'm going to copy this, and I'm going to paste it. So I pasted it down here, and I'm going to run it. And of course, it's not going to run. Okay, so the reason it didn't run is because I was using another program that was actually listening on COM port 3. So we're going to paste it, and we're going to press enter, and just wait for it. Now on mine, it might, why? Okay. So on mine, I got directory already exists. On yours, you probably wouldn't see anything. It'll just boop, it'll just go, and it won't give you any errors. That means you already wrote it there. So for me, it says directory already exists because it's already on my ESP32. So I'm going to go ahead and clear that. The next one we need is you have to make sure you're in the correct directory. That is very, very important for the next commands to work. So here we're going to copy the client inside the WebSockets folder onto the ESP32. So what we do is we tell it ampy, use port 3, and put the file, the current file in our PC inside the WebSockets folder called client.py. Put it in the folder we just created, which is WebSockets, and name it also client.py. So we're just going to copy that. And we're just going to run that. And we let it run. There we go. And when it's correct, this will happen. You won't see anything. It'll just go to the next line. That means everything is good. So you really don't want to see any kind of message. That's always a good sign. Next one is the same thing. Make sure you're on the correct COM port. We're going to copy the protocol.py. And just like that, we should be complete. Sometimes it could be a hit and a miss, depending if your ESP32 is running something. There we go. So sometimes you have to unplug and plug back in and just wait for it. So now we have the main and most important files done, which is basically the library. Now we can go into the code part. Now we can go to the main.py. This is where all the magic happens right here. So let's get started. What are we doing here? First of all, we import network stuff so we'll be able to connect to Wi-Fi. And machine is a library, and this is how you're going to be able to interact with the pins. So you could turn a pin to be high voltage or low voltage, turn something on and off. Import WebSockets client, that's the files we just uploaded to the ESP32 in order for us to be able to connect to the server. And here, I don't know why I did this again, but I didn't need to do this again actually, so we could just erase this, we could ignore that. JSON, just to make our life easier, and it's really easy with Python to use JSON. And time, in order to just time for if you want it to sleep whilst doing something, and that's why we do that. So the first thing you want to do is put the name of your router here. And case sensitivity does matter, and then your password as well, so it'll allow it to connect to the Wi-Fi. Very simple stuff. Here is your token, and that's the token found on the web panel, which is right here. Make sure you don't share that with anybody. So you go ahead and grab your token, and you can grab it from token encode, or you can even grab it from the sensors where we made it right here. So you could actually go ahead and use this token right here. So it's the same exact token everywhere. So we could just copy that. And I'm going to go ahead and paste that in there. ID, very important. This should be the exact name that you have down here. Very important, or else it won't register. It won't know that this is the device you're actually trying to talk to. So this is very important. So you take this ID right there and exactly the same case sensitivity. So LED, as you can tell, perfect. So here we get to the good part. This is where we could actually control the pins. That's the library we imported. So here we were saying LED is going to equal pin number 2. And it's going to be an output. That means it's going to output a voltage. You could also have input, but we'll cover inputs later on. That's when we use sensors. So we're just telling it just to ignore anything coming in, and there shouldn't be anything coming in. And we just want to output voltage. So we're just going to output whatever voltage we might want. In this case, we're only going to output either a positive or a negative, or ground basically. So pin number 2, where did I get that from? Well, pin number 2 is the default LED built in. It's connected directly to pin number 2, which you could also control anything else with it, but this is like the best beginner tutorial, so we don't have to solder just yet. And it's the LED I showed you in the beginning of the video. So on the ESP8266 and ESP32, pin number 2 is the default LED. Now this pin number 2 could be any pin, almost any pin, depending on the documentation, but you'll be able to control anything. So you could put a relay, which we'll cover later on, which will allow you to disconnect the power of something and connect its power just by turning the voltage on and off. And you can do a lot of things with just turning voltage on and off, which is pretty insane. Again, we're taking it one step at a time. So pin number 2 here. And if we go down here, we really don't need to do anything here. This is the default way that the MicroPython connects on Wi-Fi. So you basically get that from online, how the documentation says it. So this has to be there so it could connect to the Wi-Fi. And now this is the important part. So I wrote it inside a function called receive. So it's constantly going to be receiving data from the server. So first of all, it's going to go and connect to the server with your token. And then once you're connected, it'll print connected if we are debugging, but we're not going to be debugging here. Now here, what I'm telling it to do, while true, which means loop forever. So as we're looping forever, what are we going to do here? Well, we're going to get a command. So the command equals the WebSocket receive. So the command is going to equal whatever the server tells us to. And we're going to put it in a variable called command, so it makes our life easier when we can call it back instead of constantly calling this over and over again. Now here, text data JSON. So the data comes in as text, and we're going to convert it to JSON so we could access the different variables in that text, and it makes our life easier. And that'll make a bit more sense here. So JSON loads. So this is converting the text into JSON here. And it's that command right there. As you can tell, we just converted it. That's all we did right there. And here I'm just printing it. When you're debugging, you actually see the data coming in. I'll probably show that later on for you guys. So here we have receive ID. So what this does is it takes that JSON object that we created up there, which is the text JSON. We tell it take the ID variable, and make it into a simple readable variable so we could call it any time. Next down the line is the actual message, whether it's a 0 or a 1. Currently in this type of format, it's just going to be either a 0 or a 1, and you can do whatever you want with that 0 and 1. And again, I'll show you. So we're just taking, instead of constantly calling text data JSON message, we're just putting it into the variable message to make our life easier. Now here, this is an important part. This is to check if the current data that the ESP32 received is for it. Is it for its current ID? So what it does is it checks the received ID from the server and the ID you placed up here. As you can tell, this ID right here, that's what we're calling. So if the server sends LED as the ID, and then this will become true. And if this is true, then it's going to execute this message. So this way, when you have more than one sensor, not all your sensors or switches go off when you just click on one. So it's very important to take that into consideration. And now once this is true, so we've confirmed that the ID we just received is our ID. So let's go ahead and do this. So here we say if the message equals 0, then let's turn off the LED. So we just say LED off. It's really that simple because we already initialized the LED as pin 2. So here we're telling it make pin 2 off, and that'll turn off the LED. And the next one says elif. Elif is very important. It means else if. But if you put another if, I don't want to get too far into that. In this case, it'll be okay. Nothing will happen. But you usually want to stick to elif. So this is an else if message equals 1. So if it's a 1, we want to turn on the LED on. So let's see what's going on here. So as soon as you boot up the microcontroller, the ESP32, what's going to happen is it's going to print out sleeping for 2 seconds. And here we start a loop. So this is, again, a forever loop here, which runs for eternity. And so it says while true. Then we're going to do time sleep 2 seconds, as we stated up here. So it's going to sleep for 2 seconds, so it doesn't constantly spam the server here. And then it's going to say try. So this is very important, the try and accept. So if you don't have the try and you disconnected or an error popped up, then the microcontroller will stop doing anything. You're going to have to reset it. So here what we tell it is try. And on any error that happens, then just print lost connection and then just go ahead and try it again. It's very important you do that because it catches errors and it doesn't break the code. So here we're going to say try, print connecting. So after the connecting, we run the command receive, and the command receive is the function we wrote up here. So instead of having to write all of this down here, that's what functions are for. It's just easier way to call them. So we could just call it with one line. So we could get all of dirty code up there and keep this nice and clean here. And that's all we're doing. Here it's just going to run this code that we just covered on receiving data and checking if the ID is correct, and then turning the LED on off depending on the message. Except, again, like I mentioned, so if anything happens, then just print us a lost connection and continue. Don't break. So don't stop the program, because if it stops the program, you have to reset it. So we just tell it continue, and it'll come back up here. And it'll sleep for 2 seconds, connect, and start receiving data. If anything happens, it lost connection, boom, it goes here, and it tells it, okay, lost connection, continue again. And that's the reason why we set that up here. And it's really that simple. So I really hope that made sense as a beginning setup here. And I really highly recommend you look up some Python. It's very easy to learn as well. And this will make even more sense. I've tried to make the code as simple as possible and add as much comment as possible for you to understand what's going on here at your own pace as well. Now, once that's done, again, once you just put your SSID, which is your router's name, password, and token, and the ID of the sensor, then we're ready to flash it. So this is all you need to modify. Sorry it took so long, but I just had to explain a couple things for you guys. And now we're ready to flash it. So let's go ahead and open back our terminal here and double check you're in the correct location. Again, we can do this by doing dir and making sure our U WebSockets is there and our main.py is there as well. And you could also see from right here what it says. So we could see that we're in MicroPython project, ESP32, project 1, basic, cool. If you're at ESP8266, same thing. There's no difference there, actually, just the folder. So you can actually even run this on the ESP8266. So now our main is done. Make sure, obviously, you save it. So again, once everything has been filled correctly, then we want to go here. And what we want to do is we're going to run the ampy command again. So we can say ampy. And we're going to say port. It's really good to memorize this. It takes time, but it's really good. So we were on COM port 3, as I remember. And here, what we're going to do is we're going to do put. So we're going to put a file. And we're going to type MAI. And I'm going to press tab. Let that finish it for me. Space. And I'm going to type main.py. Don't let that finish for you. And then just like that. So what we're doing here, it's going to be difficult for you to see. Oh, actually, we can just drop this here. So here we could say ampy port, which is COM3, put main file, main py, which is this file here, and put it as main py inside the ESP32. So take this and put it in the ESP just like this. Now, if you misspell this, then your program will never run. It has to be main.py. Main.py is what runs when you boot up your ESP32 on MicroPython. So we're going to go ahead and send it. And just like that, we're done. Now we can completely control the LED through our phone or anything else if you change that pin and connect something else to it. And again, we'll take those one step at a time. And I really hope you guys enjoyed the video. Everything is linked down below. Also, if you come support me on Patreon, that would be really great because these take a lot of effort, a lot of energy, and I truly hope I'll end up benefiting you somehow or some way. And I'm just trying to enable you to completely be able to do whatever your heart desires. So yeah, any support goes an absolute long way. And also you can check the links down below, which are affiliated, and they do support the channel. And I'll see you guys in the next one. Peace.